Hi everybody, welcome to this tutorial video about pest control, which is our learning area 7, it's module 3, which is calibration. I've made a small presentation for you. We're going to talk about a couple of things relating to calibration specifically. Please bear with me as we swap around between the various screens. I'd like to ask you to also get out your learner guide for this learning area. If you page with me to page 10, we'll be able to get started and then we'll all be on the same page. Alright, so on page 10 it starts speaking about the nozzles and the spacing on the boom spray rig. We're going to specifically quickly take a look at two calculations that you need to be able to do. You need to be able to work out what the if a nozzle is safe to use or not, so whether or not it's within the 10% range that we consider to be acceptable, and then also to be able to determine what the nozzle's flow rate is, or the average flow rate. So let's take a look at the first one of those. Alright, the first thing you're going to be able to do is work out whether or not a nozzle is safe to be using. The example that you've got in your textbook or in your learner guide shows you how to do this. It highlights the different flow rates between your control nozzle and 4 other nozzles that you've tested. It says firstly measure the control nozzle. In this case the control nozzle is 1.6 liters, or 1.61 liters, sorry, which is 1,610 milliliters. Therefore we can say that 1,610 is the benchmark, or effectively 100% of a perfect flow rate for this example. So when we speak about 100% in this particular example, we are referring to 1,610 milliliters. Anything over that will be over 100%, and anything under that will be under 100%. The next step is to identify which of these nozzles has got the largest difference. We can see here that test nozzle 2 has got only 1.5 litre flow, so we know that that's one of the biggest difference. So we need to compare the control nozzle to that nozzle to determine whether or not it's within our safe range of 10%. In order to do that, we're going to divide our test nozzle by our control nozzle, and then we're going to get a number which we're going to divide times the 100 so that we can determine what the percentage difference is. Alright, let's go back a step. It says here calculate that the percentage differences between the control nozzle and nozzle 2. Alright, to see what this percentage difference is, we're going to put it into this formula. Alright, so this is our formula. This is the formula you're always going to use when you want to know whether or not your nozzle is safe to use. Alright, so step 1, 1,500 mils, which is test nozzle 2. Alright, that's that one over there, test nozzle, which we've identified as being one of the greatest difference to the control nozzle. So 1,500 divided by 1,610, and it gives us this really long number. Alright, 0.9, whole lot of other stuff. You need to be able to round this off. You can go back and check our previous video tutorials on how to round off. We're not going to go into that then. The final step in this process is timesing to the 100 to get to a percentage. So step 2 is 0.932 times 100, and that gives you 93.2%. This is within 10% difference of 100. If it was 89 or 75, it would have been more than a 10% difference. Then you wouldn't have been able to use it. Alright? But because this is only 10% difference, or less than a 10% difference, this nozzle is safe to use. So you can go ahead and continue with this process. I'm going to stop here. We're going to do a separate video for our next calculation, which is calculating the nozzle flow rate.